What if you could build an AI-powered dice roller in minutes, then lock it down so only your approved clients can use it? We'll create a secure FastMCP server with JWT authentication, generate a signed access token, and expose a roll dice tool that AI models can call, all while keeping unauthorized users out. You'll see exactly how to set this up, from key generation to token verification. From FastMCP, import FastMCP. From FastMCP server auth import JWT verifier. From FastMCP server auth providers, JWT import RSA key pair. Import random. Key pair equals RSA key pair. Generate. Access token equals key pair. Create token. Audience equals dice server. Auth equals JWT verifier. Public key equals key pair. Public key. Audience equals dice server. MCP equals FastMCP. Name equals dice roller. Auth equals auth. At MCP, tool. Def roll dice, end dice. Int list int. Roll end dice, 6-sided dice and return the results. Return random, randint 1/6 for in range end dice. If name equals main. Print f \n in dice roller access token. \n access token n. MCP, run transport equals HTTP, port equals 8000. This demonstrates the AI tool integration pattern, where Python functions become remotely callable services for AI systems. The code shows how to expose a simple dice rolling function as an AI-accessible tool, using FastMCP as the bridge between Python logic and AI workflows. The distinctive aspect is the seamless conversion of native Python into an AI-compatible API without manual endpoint definitions. The pattern works through declarative registration, where decorators like @MCP tool mark functions for exposure while preserving their original implementation. FastMCP handles the RPC layer, including type validation, transport, and authentication, so your code stays focused on business logic. This separation of concerns means you define tools as pure Python functions, while the framework manages all the integration complexity with AI systems. This approach matters because it solves the last-mile problem of AI integration, where exposing backend logic to models typically requires custom API development. It's ideal for creating lightweight microservices that AI agents can consume directly, eliminating the need for separate API layers. The trade-off is framework dependency, but the productivity gain for AI tooling scenarios usually outweighs this cost. Let's break it down. From FastMCP, import FastMCP. From FastMCP server auth import JWT verifier. This imports FastMCP, the core framework for building AI-callable tools, and JWT verifier for JWT-based authentication. These are the foundational components for creating secure, AI-accessible functions. Key pair equals RSA key pair. Generate. Access token equals key pair. Create token. Audience equals dice server. This generates an RSA key pair for JWT authentication, then creates a signed access token. The audience claim restricts this token to the dice server service, preventing unauthorized use across other services. This is the standard JWT pattern for service-to-service authentication. Auth equals JWT verifier. Public key equals key pair. Public key. This instantiates a JWT verifier using the public key from our generated key pair. It validates incoming tokens, ensuring only authorized clients can call our dice roller tool. This is the standard pattern for securing FastMCP endpoints with JWT authentication. MCP equals FastMCP. Name equals dice roller. Auth equals auth. Instantiates the FastMCP server with JWT authentication and a descriptive name. This is the core entry point that registers all decorated tools, making them callable by AI models. The auth parameter enforces token verification on every incoming request. At MCP, tool. Def roll dice, n dice, int list int. Roll n dice, 6-sided dice and return the results. Return random, randint 1/6 for in range n dice. The at MCP tool decorator exposes this function as an AI-callable tool. FastMCP converts the type hints and docstring into a structured schema that AI models use to understand and invoke the function. This follows the tool function pattern, pure logic with explicit input-output types, no side effects. The decorator handles all serialization, validation, and transport. You just write the core logic. If name equals main. Print f backslash n backslash n backslash and dice roller access token. Backslash n access token backslash n backslash n backslash n. MCP. Run transport equals HTTP. Port equals 8000. This is the standard Python entry point guard. It prevents server execution when this module is imported, ensuring the server only starts when the script runs directly. The print statement outputs the JWT access token for client authentication, while MCP run launches the FastMCP server on port 8000 using HTTP transport. FastMCP JWT authentication. This pattern demonstrates how FastMCP servers validate clients using JWT tokens, where the public key verifies what the private key signs, creating a trust chain without shared secrets. The audience claim in your token must exactly match the audience configured in JWT verifier or authentication, will silently fail with 401 errors. Always rotate your RSA key pairs in production. Never use the development utility for real deployments.
The server that demands proof forgets it was once the one who signed the promise.